All right, so let's look at this second problem. It should be a little bit shorter. So we have, in this case, we have a block sliding down a ramp. In one case, the ramp stays stationary, and so the block just slides down it. And in the second case, excuse me, as the block slides down, because it's pushing on the ramp, the ramp starts to move. If there's no friction between anything there, you assume that the block is going to go faster, but because of that, the ramp is going to recoil backwards. So when I look at that, there's kind of impulse and momentum conservation because you have these things recoiling off of each other. There's going to be some conservation of energy. Anytime anything slides down an incline or anything like that, you should think conservation of energy. And then I'm going to kind of look at Newton's third law. And so I'm going to put I didn't write it in a complete paragraph, but here are my basic points that I think go into it. It's the idea that at the beginning of the problem, for both cases, you start out with a block that's at the top of the hill. What type of energy does it have? Potential. It slides down. What does that potential energy turn into? Kinetic. And then if the plane stands, if the ramp doesn't move, where does that potential energy go? It's the kinetic energy of the block. If the ramp moves, some of the potential energy goes into kinetic energy of the block. Some of it goes into the ramp. So it makes sense that if it's attached and nailed down and doesn't move, if that block slides down the ramp, it's going to be going faster. But if they both move, it's going to be going slower.